Hello and welcome back. I'm Matthew, and today we are going to take a look at importing data from CSV files into physical files under IBM I. So let's sign on. Now, if you recall from the last video, we created a database table, or what's called a physical file in IBM I, to hold data on Messier objects. These are astronomical objects, galaxies, nebulas, star clusters that Charles Messier cataloged a long time ago. So we created that, and we used the data file utility as a quick and dirty method to input some of our initial records. You'll recall that was very unfriendly. You had to pad all of the numeric fields with the right number of leading or trailing zeros so the decimal point gets in the right place, and things like that. Now, I have a CSV file with the Messier objects in it in a format matching my database table. So if we look at, let me quit out of that. Let's remind ourselves what our database looks like, or our DDS definition of the database. So we will display our Messier file. I made a couple of tweaks since the last video, but essentially we have the object number, that'll be 1 through 110. We have the NGC identification number for the object if it has one, the object's common name if it has one, many don't, the distance from Earth in light years. I removed the decimal positions on this one just because when we're talking light years and objects that far away, getting down into decimal precision is probably unnecessary. The abbreviation of the constellations it's in, the apparent visual magnitude, right ascension, and declination. The other tweak, right ascension, I'm now going to use decimal degrees instead of just a straight decimal conversion of the 24-hour system. Using decimal degrees is more customary. So in any case, that's what that looked like. We compiled that to create our physical file, and we used DFU to enter some records. So let me switch out of the terminal emulator here. And over here on my local system, I have a CSV file with the Messier objects. And it's that same format, the Messier number, the NGC number, the name, the distance in light years, constellation, magnitude, right ascension, declination. That's where it is in the sky. So given this file, I want to load all of this data into my physical file over on my IBM I system. So the first thing I have to do is get the file up there. Well, I can FTP it. So I like NCFTP because it has tab completion and who likes to type. And we can log in as my username and the host name I'll connect to. All right. So we have seen all of the objects in libraries on IBM I. That's how its native file system works. IBM I also has what it calls the integrated file system. And this is the Unix-like file system. It's the directory hierarchy with files like we're used to from most other operating systems, including Unix. So I can go into, just say, the temp directory and set my file format to ASCII. And then I can upload my Messier objects.csv file. And I have another file there, constellations. This is the map of the constellation abbreviations to their full names. That might be nice if we want to look at doing database joins later against that Messier object table. That could be something we do in a later video. So I'll go ahead and put that up on the system as well, and we'll import that. Okay. I've uploaded the files. Let's go back over to our IBM I system. Now, we can look at that integrated file system in a Unix-like environment, which is accessed through Q shell, I guess is what that stands for. So I can go to that temp directory. We can see that constellations and Messier objects is there. I can take a look at that Messier objects.csv file. And we can see that, sure enough, the file made it up there. That's good. We'll note we have column headings here. So we don't want that row to go in as data, and we'll have an option to exclude that we'll see. All right, looks good so far. We'll exit QSH. And I think what I want to do is create an error file. We'll see that the import CSV command allows us to ask it to put a copy of any records that it rejects for some reason into an error file. So an error file is a source physical file, and it needs to have a member in it that is ready to receive those rows that may have been rejected. So we can use the create source physical file command. I'll prompt that with F4. And the file I want to create, we'll just call it errors. I'll put it in my current lib. I think it's in Wilson, but I'll type that in explicitly just to be safe. The member name, we'll go ahead and create a member, and this will just be a blank member. And we can call this error records from CSV import. Okay. Looks good. File errors created in library in Wilson. Perfect. So with that, we have our physical file already exists. Remember, we created that last time, and that already has those 3 rows in it that we just looked at a minute ago. So what we want to do is take that CSV file and import those records into our Messier file. And any rows that are rejected are going to go into that errors member inside of the errors file. So we do that with the copy from import file command. Now, I don't quite remember exactly what the command is, but I know it starts with copy. So one of the nice things I can do is just say copy star and hit enter. And I will get a list of all of the commands that start with CPY. And sure enough, there's the one I want, copy from import file. So we'll select that command, and we'll get the prompt screen for that command. Now, we talked about the integrated file system, which is where we put our CSV file, as opposed to everything else we've seen so far, which is the, I guess what you'd call the object file system, that is the IBM I native file system. So wherever you see from stream file instead of from file, the stream file is where I can put in a path to that integrated file system. So we uploaded those to temp, and it was called Messier objects.csv. And then I'll just leave from file blank because you just do one or the other. In this case, I'm doing from a stream file. To database file is what database do I want to load those records into? Well, that's Messier in the Wilson library. The first member is what we'll always use on database files. And we can replace or add records. Now, remember, I already have 3 records in the database. So those 3 keys are going to conflict with 3 keys in my CSV file. I can use the update or add option, which will update the data on any existing records where the key matches, or add any new records. So that sounds good to me. I'll update add. I'll hit enter. Now that the prompt screen knows a bit more about what we're doing, I get an extra option, the stream file record length, to file, that's fine, that's the default. Hit enter again, I get more options. We can see the record delimiter. Now in this file I uploaded with the FTP client set to ASCII, this ends up putting CRLF as the line ending. And if we hit F1 here, you can see that we have these various options, but yeah, CRLF is an option. So I'm going to use CRLF. The format of the import file, of the CSV file, it's delimited. So that's perfect. I'll hit enter again. String delimiter, double quote. If you remember from the file, we didn't really have anything complicated. There weren't any quoted strings. It was just a plain comma-separated file. So we can leave the defaults for the escape character and the quoted. This is if you have commas in your text values. It's typical CSV stuff. So you have the flexibility here to set that up the way you want. Decimal point, we have a period. Again, we're not having to pad those decimal values out to get the decimal point in the right place. It will just read them as you would normally type them in. It can round numbers if you have greater precision in the file than your database field allows. So it really is pretty forgiving in terms of the exact format of the data that's in the CSV file, especially compared to that data file utility we saw where you had to get it exactly right. Okay, let's hit F9 just to expose all the fields here now that we're at this point. Field definition file, this is if you're importing a fixed width field. We're not, we're using CSV, so we just depend on the delimiter. We went over those options. We want from the beginning to the end of our input file. That's good. If you're doing times, you saw some time options. We'll allow any number of errors, and we'll just keep on going. But remember, we made that errors file. We would like the error record file to go into errors in the MLSN library, and the member we created was errors. And we'll just add error rows to that file. We don't have an identity column, and remove column names. This is the last important option. Remember, the first line of our CSV file had the column headers. So if we get help on this field, it says, do we want the column names to be removed from the file? And yes, we do. So yes means the copy will begin with the second record from the file because the first record contains the column names. Perfect. That's exactly what we want. So there's quite a few pages of options here, as you can see. Remember, we can go F14, which is Shift F2, to see the command string that it's built. So again, even though this command copy from import file has all of those options, we're really only changing a few away from the default values. We're saying it's from a stream file, which is that file we FTP'd up to our system. To file is the database we're going to. We want to do update or add so that we're not conflicting with existing records. We're just updating the data on existing records in the database if they already exist. We have the carriage return line feed as the record delimiter. And we would like the errors to go into this errors file, into the errors member. And we're going to remove the column name because the first row of our CSV file isn't data, it's the column names. Hit enter, hit enter. Aha, interesting. So 32 records were copied to member Messier. Now I know that there are 110 Messier objects. So, seems like something went wrong. Let's take a look at what we got first. So starter SQL, select star from Messier. And now that we have a bunch, we can order by Messier number. Okay, so a lot of data did go in. We only had 3 records before. It looks like all the data is formatted correctly. If I go over to the right, you can see right ascension declination in particular has reasonable values. Remember, this was a pain to enter through DFU, so it's nice that it just reads the decimal values from the CSV file with positive and negative just fine. That's nice. What I'm noticing here is, with the exception of the record that we had already manually entered in the last video, I'm only getting objects that have a name. Everything that has a blank name, which were the majority of the records in the CSV file, don't appear to be there. Okay. Let's go out and look. If we start PDM, let's look in that errors file that we created. Okay, there's errors. Let's display that. So this doesn't tell me why the record was rejected, and I'm not sure if there's a way to get a more detailed error log, but we can see here each of the rows from the input file, our CSV file, that didn't make it into the database. They were just put into this errors log instead. And sure enough, most of these look like they are blank in the name position. Now here's one that does have a name, but the NGC number is blank. So there's something going on with having blank values in the CSV file. And it turns out what is happening is blank fields in the CSV file are treated as the null value as opposed to the blank value. So if you're familiar with SQL databases, you know, there's a difference between the empty string, a string with length 0, versus the concept of null, which is kind of an explicit value unto itself. And my DDS file does not allow the null value in any fields. They can be blank, but by default, when we import, the blank CSV values are treated as the null value instead of a blank or an empty string. So there's a couple ways we can address this. The easiest is if we go back out, I can hit F9 to retrieve my command history, and we're back here on our copy from import file command. So I'll hit F4 to prompt that, and I get back the options I used, so I don't need to retype all of them. So we can confirm we're coming from the CSV into our Messier database. I'm going to update or add, and if let's hit enter here. Okay, CRLF, perfect. Let's see, hit F9 to get more options. One of these options, let's look for it. Replace null values. So no will, in fact, we can bring up the help here for this and make it a bit bigger. No will keep blanks as a null value in null capable fields. Otherwise, an error will be sent. That error was that row got sent over to our error file and not into the database. I can change that to field default, and a null value will just get turned into whatever the default value for that database field is, which is, in the case of a numeric field, 0. In the case of a text field, it will just be the empty string or all blanks. So that sounds like what I want, field default. Let's go ahead and change this value to field DFT. And when I run the command this time, there we go, 110 records copied to member Messier. And now if we go back and we select star from Messier, order by Messier number, that's much better. So we have all of the objects, and if they have blanks, that's fine. And we saw, yeah, there we go. So some of them had blank NGC numbers. Because this is a numeric field, those are now showing just as 0 for where we had a blank value in our CSV file. So that's great. Those are all of the Messier objects. Perfect. Now, what was this about nulls? What if we want null to be a valid option instead of, this isn't NGC number 0. There's just no NGC number to associate with it. So let's go back to our DDS where we defined let's just get back to the start here. We can start PDM. Let's work with members, and let's work on our database definition. So that was in QDDS source, Messier. Let's go ahead and let's copy this into a new member, and I'll just call it maybe Messier in for allows nulls. All right, let's edit this guy. And aside from saying we wanted unique keys, we didn't really use the functions position on any of these fields that we defined. So this is an example of where functions can be used. If I want to allow nulls, I'll prompt this field or this row, and one of the functions is allow null. I lied. It's not allow null. So I might have that a little bit wrong. I can just hit F1 for help, and I can see all of the functions I can use here. And okay, that's the problem. It's 2 L's, not 1 L. So again, really nice always having this field context-sensitive help in the source entry utility. So NGC, this numeric field, can now allow null values. Name was the other optional field, so we can put allow null on the name field as well. And then everything else should always have a value, so we will quit out of this, save that. And if we compile this new file, we should get a new source physical file called Messier in. It won't override our old one because it's a different name. By default, it'll create this source physical file or this database table to match the member name. So we'll compile that. It's created, so that's good. Let's go back out and just to kind of prove everything's above board here, we'll select star from Messier in. So now we have a new empty database table that we just created. And let's see, if we do enough command history, we should still have our import command, right? Yes. So let's hit F4. We now want it to go into Mezzier in, our new table. Update add is fine. All of these other options should be good. And where did we set field default? Yeah, we don't want this anymore. We'll go back to the default of no. We're not going to replace null values. And this time, it accepted all 110 records, even with nulls. So if we go back and look in SQL, select star from Mezzier in, now you'll see there's a subtle difference, right? And these that don't have a name, there's a dash here, and that's showing us that that is a null value. It's in this particular tool, right? That little hyphen character isn't stored in the database as a text value. This is just how this tool indicates a null. Similarly, we can see in the NGC number, it's not 0 anymore, it's null. Something else to point out, I had a shorter field defined than some of the names I had in the CSV file. But again, instead of being an error, it's just going to truncate those for us. So again, it's pretty forgiving in terms of trying to take the value that's in the CSV file and make it conform to the field specification, which is much nicer than trying to type that in that data file utility. So that's pretty neat. We have null values now in this database, and we imported all of our data from a CSV file. It's formatted nicely. All the decimal stuff worked out correctly. I like that. That's a neat tool. It works well. So the last thing I'm going to do, just as kind of a teaser for maybe a future video, is let's make another database table that has the full constellation names for every abbreviation. So as a refresher from last time, this will just be a quick DDS definition exercise. It's in our DDS source. That's good. We will hit F6 to create. Let's call this constellations, and this will be a physical file source. Constellation, let's say abbreviation to name mapping. And we can IP for insert prompt. We want the key to be a primary key, so we put in the file level unique keyword. Then we define the record format. We'll call it constellation record. And then we start entering our fields. So really, we just have the constellation code, which is a 3-character alphanumeric field. And we have the constellation name, which is a, let's give it, I don't know, 20 characters alphanumeric field. Both of these are always going to have values, so we don't need to worry about that allow null like we added to a couple fields before. And we want our key to be the code. So I think that's everything. It's just a simple 2-column table, 3 characters for the code, 20 characters for the name. And because we have a key identified and the word unique, that will make code a primary key. Perfect. Save that. And we will compile that with option 14. So now we should have the constellation table. And if we copy from import, what was it? Copy from import file. Yep. We can do this again. And we uploaded the constellations.csv. Is that what it was called? We'll put that in our new constellation file. In this case, we can just add records because there's nothing in the file already, so that should be fine. Record delimiter, CRLF. On these stream files, I'm not sure how sensitive is to that, or all might. We'll see what happens. Actually, all might work. We'll stick with what works, what we know works. CRLF. Record format delimited, perfect. That's all good. The separator's that. Does anyone remember if we had a header column? I do not. Let's look at constellations. Okay, constellations does not have the column header, so we will, let's see, F9. That's all good. That's all good. I'm not, well, yeah, just in case, let's say, in case any rows are rejected, we do want to know what those rows were. And we can leave that to no, because again, there's no blanks this time, so we're not going to run into that problem, and we're not going to remove column names. So if we look at this command, let's see, I always forget F4s. Okay, F14. So again, this is even simpler because we're using more of the defaults. We're just saying from the CSV file into this database, here's the record delimiter, and here's where I want my errors. So let's go ahead and run that. And 88 records were copied in. And so if we start SQL and select star from constellations, there they are. Looks good. All right, so we're starting to build up this little astronomical information database. We have our table of constellations, and we have our table of, oops, spelled that wrong, from Messier. And we have our table of Messier objects. So at this point, we'll be able to start looking at querying. We'll be able to join on this constellation column so we can get the full constellation name for people who may not be familiar with the abbreviations. And we want to create a little printout of, you know, here's what you can see and here's where you'd look in the sky. But we'll leave it there for now. Again, being able to import from CSV is obviously a pretty important capability anytime we're dealing with databases when we have existing data that we want to get into our new database tables. And as you can see, that copy from import file command is quite capable on IBM I in terms of some of the nuances of the data that it can handle in the CSV file coming in, as well as the options I have to put it into my database tables. So hope you like that. Go ahead and like and subscribe as usual if you enjoyed this and would like to see more. In any case, I appreciate your time watching the video, and we will see you again soon. Goodbye.